Okay, in order to solve this equation, we want to first pick a variable to eliminate. Okay? So, first we pick a variable to eliminate. Do you want to eliminate A or B? Okay, there are two ways I would look at this. And it doesn't really matter, you could eliminate either one. Okay? Might be easier to eliminate B because if I multiply by the right positive numbers, these things will end up with opposite signs. So when you add them, they go away. Right? On the other hand, the coefficients of A are smaller than the coefficients of B. So you'd probably end up having to multiply by smaller numbers. But these numbers aren't that big, so there's no point in worrying about it. We can go ahead and do that. So, in order to get the coefficients of B to match up, I'd have to multiply this equation by some number, and this equation by some other number. Okay? So, what are two numbers I could multiply by? What could I multiply this by? And then what could I multiply this by so that the numbers in front of B would end up equal but opposite? Well, I'll show you. We'll call this equation 1, we'll call this equation 2. I multiply equation 1 by 5 and equation 2 by 6, then what am I going to get in front of B here?
You would get, would it just be 10? Wait.
No, if I multiply everything in this equation by 5, if I multiply both sides by 5, what am I going to end up with in front of B? Like, what's 5 times negative 6? It's what?
Negative 30.
Negative 30, right? If I multiply the second equation by 6, what am I going to end up with in front of B?
30.
30. Okay? So, I multiply the first equation by 5, remembering to multiply both sides by 5, right? And multiply 6 by 3a plus 5b, and make sure I multiply the right-hand side by 6. That's a legal operation. If I multiply both sides of the equation by the same number, the equation still, if it was equal before, it's going to be equal after. In other words, if this is equal to this, then 5 times this is equal to 5 times this. Has to be. Okay, we simplify this. Well, when we simplify, I'm not going to write out the details, but we have to use the distributive law here. So equation 1 becomes 10a minus 30b equals 20. Equation 2 becomes 18a plus 30b equals negative 48. Now, when I add the two equations, what do I get?
Negative 18.
Again?
Negative 18.
Okay, on this side I get negative 18. So on this side I have negative 18. How many b's am I going to have? None, because I got negative 30 of them and plus 30 of them, right? How many a's am I going to have?
28.
So, okay, so I get 28a equals negative 18. Solve for a, I get a equals negative 18 over 28. which is negative 2 times 3 times 3, breaking this down to prime numbers, over 2 times 2 times 7. Okay? Well, I could group this 2 with this 2. I'd have 2 over 2, which is just 1, right? So knowing that this 2 over this 2 is 1, I just don't bother writing it. I've got the rest of it, right? Now, your book, those books will draw lines through these things and do that C word thing that I forbid, because people do it wrong. People will not learn the rules for that operation, so that's not even, in my opinion, a valid operation. But you can group this. You could rewrite this as 2 over 2 times 3 over 2 times 7, because of course your rule for multiplication says, well, if I want to multiply this out, I'm going to end up with 2 times 3 times 3 in the numerator, right? And 2 times 2 times 7 in the denominator. But of course 2 over 2 is 1, and 1 times this is just this, right? So I get negative this. Now there are a couple more steps I could write out. And I do have a optional assignment. I was going to give a quiz to see who needs to do that optional assignment or not, but I think most people probably need to do it. So I'm going to kind of assign it for you guys for this class. On this whole process, fractions. Dealing fractions in terms of rules instead of superstition. Okay? And building the rules and doing the prime factorizations and stuff. It's simple enough. And I think you'll understand. I think you'll be able to do it fairly quickly. But if not, it just means you need to really brush up on it. Because if you're not aware of these rules, when we start doing all this with symbolic expressions, it's going to be like you have to go back and start learning it again. Okay? Whereas if you understand these rules, it's easy. Okay, so anyhow. Okay, so we've started with these equations. We've figured out what to do to eliminate B, and we solve for A. Now we could have eliminated A instead, and we could still do that. Okay? If we multiply this by 3 and this by negative 2, same thing's going to happen, except the A's are going to go away. Okay? And we would get B. But instead of doing that, well, we find that A is negative 9 over 14. Okay? So we plug this value in to the original equation. And we'll just pick the first one because it's harder to get that arrow to go to the second one. But we could have used the second one just as well, okay? And this gives us then the equation 2 multiplied by negative 9/14 plus 6b equals 4. So what are we going to do with that? Well, the first thing I would do with this is I would go ahead and multiply it by the 2. I get negative 18 over 14 plus 6b equals 4. Okay? Now, normally I would simplify that fraction, and it would be fine to simplify it to negative 9/7. Okay? Matter of fact, it'd probably be a good idea. Not necessary, though. So my general, more or less universal advice, as soon as you get a fraction, as soon as you get the expression and you got denominators, you multiply by those denominators. You multiply by any common denominator The least common denominator is the easiest. But right now, the only denominator you have is 14, so we multiply by 14. Distribute. Now what's 14 times negative 18 over 14?
Probably gonna take a Saturday. It's not hard. It's just gonna take me 5 minutes.
It's not part of your solution, but that's how you multiply 14 by negative 18 over 14. That's how you multiply any two fractions. Okay? In this case, why did you multiply this thing by 14? Because that gets rid of the 14 in the denominator. Gives you just old negative 18, which is a lot easier to deal with than a blame fraction. Okay? And you haven't hurt the equation a bit, except you made some of the numbers bigger. And maybe that's painful, but it doesn't hurt as bad as working with the fractions. Okay? Especially since fractions aren't very well taught in our curriculum. So what's 14 times 66? Must be 840 plus 84, which is 924, but don't necessarily believe me. And that's 924B. Well, numbers are getting out of hand, but so be it. Okay? So we solve that. We add 18 to both sides. We get 924B equals 74. So that B equals 74 over 924. Okay, well, can you reduce that? There's a couple of ways to reduce things, but the way I'm advocating in this course is you factor them. So over here we say, okay, let's see. '74 is 2 times 37, isn't it? And 924 is 2 times 462. Okay? Yeah, just to complete this, that's 2 times 231. And that equals that can't be right because I just checked division by 7, but I didn't do it right. Okay.
Chef Heather sounds amazing.
I did a mental, had a mental error there. And I really had a mental error. I'm treating that like 131. Anyhow, 231 is divisible by 3. And I'm writing this down, messing it up completely. I want to keep things in order. Yeah. 2 times 3 times 77. In other words, I can divide this by 2. I can divide this by 2. And didn't write down that 1, 2. Okay, see what I'm doing? 924 is 2 times 462. 462 is 2 times 231, so 924 is 2 times 2 times 231, right? And the 3 goes into 231. Not difficult to figure that out. There's a rule for dividing by 3. If these numbers add up to something that 3 divides, then the number is divisible by 3. These 3 numbers add up to 6, you can divide that by 3, so it's divisible by 3. You don't have to know that, you can just try 3. Okay? So you got 3 times 77. Is 7 times 11. Now all these numbers are prime. So you say that B equals 2 times 37 which is this, which I could write as 2 over 2 times 37 over 2 times 3 times 7 times 11. And now nothing up here matches anything down there. Now why did I stop at 37? Because ain't no other number divides 37. 3 doesn't divide it. 5 doesn't divide it. And if 7 was going to divide it, it would give you something less than 7. You would have already found it. So that's 37. Multiply that back out, you're going to get 462. And then you check. See if I did this right. And there's a good chance that I didn't, because I thought I'd have numbers that would come out even, but they didn't. Okay, now we're going to check that. How do we check that? We check that by substituting into an original equation that we didn't already substitute nothing into. Since I was letting my sentence get away with me, I figured I'd make it really good. Okay? Well, that would be the second equation. It's 3a, so that would be 3 times negative 9 over 14 plus 5 times 37 over 462. And if we did this right, that should equal, I'll put a question mark over the equal sign, that should equal negative 8. But I pretty much guarantee you it doesn't, because it doesn't even come out negative. Maybe it does, yeah, okay. But it doesn't come out negative 8. Three times negative 9/14 is 2, negative 2. That's not 2. So there's a mistake. So I pretended to make a mistake so I could make the point of, if you got a mistake, you got to go back and fix it. Except we're out of time, so I don't have to. That's the process. Now you might go through it yourself and see where I messed up. I'm not sure where I messed up. Oh, 20 minus 48 is negative 28, isn't it? Not negative 18. Okay? So that's the problem. But go back and change that to negative 28, then A is just going to be negative 1, and then your numbers are going to come out a lot neater, right? However, you need to also be able to do it for the fractions, which is why you're going to have to brush up on fractions. Okay?
I don't know.